In math, we use the terms ratio, proportion, rate, and percent to describe relationship between quantities. They all are somehow related to each other, but we use them depending on specific contexts. They all can be expressed as fractions. We know a fraction is part out of total. For example, there is this circle which is being divided in 4 equal parts. If I shade a part of the circle, then the fraction of the shaded circle is 1/4, because one part out of a total 4 parts is being shaded. A ratio tells me about the relationship between two or more quantities, or it tells you how a part of a quantity is related to a part of another quantity. For example, there are 2 teachers to manage 30 students in a school. Then the ratio of teachers to students is 2 to 30. For every 2 teachers, there are 30 students. I can make this quantity I can scale up or down these quantities. I can double the quantity of teachers, or I can make it half. So if I double the quantity of teachers, then I have to double the quantity of students as well to get like 4 teachers manage 60 students. Now here I'm talking about proportions. Proportions are used to scale the quantities. By making sure the original ratio remains same, I can find like the equivalent fractions or the ratio for this particular ratio. I can scale this down as well. Like I can find how many students will be there for half of the quantity of teachers. So if there is 1 teacher, half of 2 is 1, then the number of students will also get halved to have like 15 students. 1 teacher will manage 15 students. Now here I'm talking about a specific thing called rate, where I'm comparing a part of a quantity to one part of another quantity. We usually use rates to describe things like speed or like density, where I'm comparing how much of a quantity is there in one part of another quantity. So if I say like kilometers per hour, I'm trying to find how much of the distance is covered in 1 hour, or how many meters are covered in 1 minute or second. Here I'm talking about the rate. Percent tells me how many parts are there in total 100 parts. So always this part is fixed for percent, that is 100. So if I say like 75%, I use this symbol to describe it's a percent. So 75% is 75 out of 100. Now let me use a similar analogy to explain you all these concepts. So here there is this large pizza which is being divided in 5 equal parts. Although they don't look equal, but let's assume they are equal parts. So now we will try to see what do we mean by a fraction, a ratio, proportion, percent, all these things. So here I say like for every 3 slices of pepperoni, there are 2 slices of cheese. So the ratio of pepperoni to cheese is 3 to 2. Here I'm talking about a ratio. If I have to find the fraction of cheese slices in this pizza, so how many cheese slices are there out of a total number of 5 slices? So that's 2/5. So I have the fraction of cheese slices is 2/5. So here I'm talking about fraction, or I say 3/5 pepperoni slices are there. If I have to express it as a percent, so what's the percent of cheese, or what's the percent of pepperoni? So I have 2 parts of, 2 out of 5, 2 parts of cheese out of a total 5 parts. So how many parts will be there for 100? So I can go from 5 to 100 by timesing it with 20. Then I times this also by 20 to get like 40. So the fraction, the percent of cheese slices, this percent of number of cheese slices in this pizza is 40%. And the remaining 60% will be for the pepperoni slices. I can also say like proportions here. So like if I have 3 pepperoni slices for every 2 cheese slices, then how many cheese slices will be there for maybe 12 pepperoni slices? So here I have scaled up. So I did times 4. 3/4 is 12. Then I do times 4 here as well to get 8 as for cheese slices. So for every 12 pepperoni slices, there will be 8 cheese slices.